All right. Thank you all for coming to our distinguished lecture series today. Melvin McInNIS is our guest. He's coming to us from University of Michigan, where he's the Thomas B. and Nancy of John Professor of Psychiatry, and also head of the Heinz C. Precher Bipolar Research Program. He did his undergrad at University of Manitoba in Canada, and then he went to Iceland to get his medical degree from University of Iceland. And during that time, he was telling me that he became more and more interested in bipolar disorder. He had an experience with a particular patient where he found it fascinating. And that caused him to get more involved in bipolar research, and he completed his specialty training at University of London before moving to Johns Hopkins, and then eventually relocating to University of Michigan. He has been extremely prolific during his career. I was talking to him last night. His H-index is close to 100 at this point. In fact, one of my sisters before his talk was telling me, she's like, that guy Melvin you constantly talk about, like, he's the world-leading expert on bipolar disorder. I was like, yeah, I knew that. Like, I'm glad you now recognize that as well. And he truly has had a phenomenal impact. And I think part of that, the reason why from working with him, from getting to know him, is he doesn't just view research as theoretical. He also recognizes the importance of clinical impact, and he sees them as going hand in hand. So he's had truly a tremendous impact on not just his patients, but also on the research community as well. And I'll let him fill you in now on his research. And thank you, Melvin, for joining us today.
Thank you very much. Thank you. Thank you for the invitation, and it's just been my just a pleasure and honor to come here to visit with you all. It is, of course, incredibly impressive, the campus here. It's just a delight to visit. Anyway, so I just wanted to tell you a little bit about the Prechter program at the University of Michigan. It has significance for me and for others. So it was established after the death of Heinz Prechter in Michigan. Heinz lived with bipolar disorder. He was an incredibly successful businessman and was dedicated to his community. And his business success came from developing the sunroof. So in the 1960s, 70s, and 80s, and that he made the sunroofs for cars in Detroit, Michigan. And so he made a tremendous amount of money on that. He was a very successful person. He was highly successful in the community, owned a number of business, and was just a tremendously community-oriented person. And after his death, the family pledged money to the University of Michigan to engage in research for those with bipolar disorder. And so you can see a picture of Heinz here in one of his cars, just an incredibly charismatic person. And even to this day, people tell me, you know, I knew Heinz, and he was just a phenomenal, amazing man. Yesterday, as I was preparing for this talk, you know, it was a rainy day, and I was sitting in my chair just looking, and I said, you know, I really feel good, you know, and I was really just enjoying the ambience and this, and so I realized that this was what I was used to in Iceland. When I lived in Iceland for a total of 12 years. 3 of my grandparents are from Iceland. One of them is from Scotland, which is why I have a name McInnis, and that's the paternal grandfather from Scotland. But I could have been named something like Þormóður Guðjónsson or something, you know, like that, a very strong Icelandic name. And so this is Iceland in the rain, but of course Iceland has also a different. It shines there as well. This is a trip that I made in Iceland in 2014, and these are pictures that I took from that trip. So it's spectacular in the sunshine. It's very moody in the rain, but it's just amazing. So in Iceland, we also have low pressure zones like this, and so you can see, you know, the winds are going not as fast here. It's a little bit more formed, and because the temperature of the water is obviously much lower there, so these low pressure zones and the storms don't get as bad. And so here's a picture of Ragasa, you know, brewing along here. So as I was looking at, this is Wednesday morning at about 8 o'clock, which is when my flight was due to leave, and I thought, this is not a good thing, you know, and so that it's going in the range of 940 millibar, which is, kind of a pretty low pressure zone, and we were talking about that these things can get really, really intense. Oops. So the objectives of the talk today, so I'm going to be reviewing a predictive model that recently came out, actually published last week on this. And so I want to also differentiate between classification systems and ontology and really impress upon you the importance of ontology and the basis of ontology and phenomenology and that. And so the applications of artificial intelligence and these phenotypic clusters. So why now? Well, psychiatry, as many of you know, and from the questions that we've been talking about in the interviews, is a very complex system. It's a complex phenomenological data. What are the experiences that the individuals go through? And, you know, the point that I want to make is that, you know, in other fields of medicine, what is sepsis? You know, and when I was a medical student, you know, sepsis was very clear. I mean, you had bugs in your blood and things were bad. But they've come to refine that as a dysregulated response of the body to a foreign, to a foreign pathogen. So it's a much more complicated concept than just having a positive growth. So we need structured computational frameworks around which to organize our ideas and thoughts. So this is the title of this manuscript that came out last week, Learning the Natural History of Human Disease with Generative Transformers. And so the investigators, it's a spectacular paper that anyone's interested in AI should take a look at. This is the PMID of the paper. It came out electronically the 17th of September. And this is a GPT-based model. Now, the interesting thing about it, and they're saying, well, the accuracy is comparable to that of existing single disease models. And so we're going to look into exactly what that means. So it was trained on data from the UK Biobank. So the UK Biobank is a system in the United Kingdom where health information is uploaded into this banking system so you can access it and get all kinds of health data on it. And it was validated in an independent set. So this is another key word here, the validation of it in the Danish individuals. And they're pointing out it's predicting the course of 1,000 diseases simultaneously. So it's going into all the health record data and looking to predict what's going to happen to these individuals over the course of time. Brilliant, right? Absolutely brilliant. Now, until you start looking under the hood, and we're looking under the hood, we find that the area under the curve, the sensitivity specificity ratio is like 0.76. And this is the average, what it's finding. But it's saying, it's capturing temporal dependencies and looking at comorbidities and mortality risks after cancers and so on and so on. So on the surface, it looks really, really impressive. And one should be impressed with exactly, what they did. Now, the limitations. What are the limitations of the approach? So there's a slight bit of generalization. They're predicting broad outcomes, for example, cancer, and they go into breast cancer a bit, but the nuanced individuality of it is, potentially problematic. Simplification, reducing risk factors. We all know that smoking causes risk factors. We all know that obesity is related to cardiovascular diseases. Now, the other thing that to give you a heads up on is that there's a training bias in any of these AI, systems. So it's trained on these Northern Europeans, and so they have the Brits in the UK, and then they just go across the way to Denmark, and they said, yep, we can do the same sort of thing. It's really the same, databases, and so. There's artifacts from the contamination of the hospital versus self-report. Now, the other thing, as we were talking about at lunch, the statistical nature of large language models. And so this is based on probabilistic models, based on what to expect next, and so on in the in the system. Now, I mentioned digging down into the into the AUCs with the confidence interval. So whenever you look at something, with an area under the curve, you want to make sure that you're looking at the confidence interval. Why? Because the confidence interval can give you the range where you're looking at an AUC of 0.66, which is not overly predictive. And so an AUC of 0.5, as you recall, just means that it's a 50-50 chance. And so I could make a guess and I'd be right half of the time or wrong half the time. So getting up into the 0.66 is great. And so I've been involved, in studies that we've had an AUC of 0.76, and we could not get investors, excited about that. And so they say, yeah, well, it's a promise, it's a promissory note. They say, come back to us when you've got an AUC of like 0.85, kind of consistently. So the other thing that just to point out, so things like common diseases, what we're worried about in the population, like diabetes, it was actually inferior to the hemoglobin A1C measure, which is just a laboratory measure that you can take at any given time to predict whether the individual is coming up with, will be at risk for diabetes. So here's another, looking at the area under the curve for cardiovascular diseases, and you're looking at here, the Framingham predictive value, 0.69. This is just something that's calculated, from the medical records, 0.69, and the transformer, again, 0.69. So it's just, it's doing exactly what you could just calculate from the, from the medical records. So I just want to emphasize this as a limitation of these GPT models and overall, and this is a really terrific way to understand them. The point being that it's impressive what they've done because they're looking at a large number of diseases in one shot. And where it will be important is when you're looking at planning for outcomes and services in healthcare systems. And so it'll be very helpful to know, what is the risk of, this larger population developing these particular types of diseases. So it's important to have the understanding as to where this is going to be useful. And so then I just took the liberty of looking at, the AUC of 0.6, and there's only 2 or 3 of the, the illnesses here. This is just ICD-10, the arenas that the AUC, the confidence intervals, is above 0.6, which is, there's just to be aware of the limitations on that. Okay, so what I'm going to be talking about today relates to ontology, okay? And ontology is just how we organize ideas, thoughts, and, and their relationships with each other. So it's fascinating over the year. I've been interested in this about 3 or 4 years. And often when I start talking about ontology, people rapidly start contemplating their shoelaces and say, yeah, Melvin, that's a really interesting kind of a thing. But, we really need to get down to the business of understanding exactly what causes this disease. And we want to get right to the heart of the matter. And as I said, that's a great idea. But, we've been working in genetics now for 30, 40 years, and we've not really yet come to, a clear understanding as to what causes it. And so maybe we need to get into ontology. Now, the large language models, as we talked about earlier, there's statistical associations, things. So what is the likelihood of another word following another word? We're looking at, you make it more complicated by looking at the matrices and that. And so all, the ontologies, they provide defined entities and relationships. And so types of cancer, disease stages, they have semantic interoperability. In other words, we can take words and translate them from one system to another. So we can know what a word means or what a concept is from one system to the next. It provides a mechanistic grounding for explainable AI. Now, what is a mechanistic grounding? So we had the large language models that were just plowing through the data, and they plowed through the data in a manner that is statistically oriented, and you need a large computer system and lots of energy and power to get it, and it gets through it, and you will find something. There's no doubt about that. But the mechanistic grounding provides an ontological-driven approach for preventing overgeneralization, reducing bias by harmonizing diverse data sets. And so, getting to the mechanistic basis is I'm getting out. So The way forward, so we want to structure knowledge. We want to be able to define entities. We want to capture temporal causal relationships. We want to have semantic interoperability. We want to have the ability to reason out things. We want to be able to be more precise and to develop a personalized relationship between these concepts and terms. And I'll be providing more detailed examples of this momentarily. Medicine, by and large, is driven by classification system. Now, a classification system is, the disease. So you have a disease entity, and in psychiatry, a classification system is, it's just an entity. You have depression, major depression. It has criteria, and you make the diagnosis. It's structured. It's flat, loosely hierarchically. So you have different types of depression, and it's a very simple membership. Major depression belongs to mood disorders, and it really is for clinical communication, billing, and administrative use. And so this card is just to show you the speed at which we go through this. And so in psychiatry, mental health, we have the DSM-5, category-based, low granularity. For example, if you look up in DSM-5 and thinking about sleep disturbances, you can either have too much sleep, too little sleep, or whatever kind, as long as there's some kind of a disruption in your sleep that meets the criteria. But the granularity of that is woefully missing. Likewise with the ICD-11, very, very granular, or very low granularity and billing focused. Heterogeneous disorders, they are. Major depressive disorder, one of the more common illnesses that we talk about in psychiatry. This is what I use ChatGPT for, is to find the number of combinations of the symptoms that you could have to get to the diagnosis of depression. So 227 different ways of being diagnosed with major depression. Likewise with bipolar disorders. And so these mood disorders, they defy rigid categories. Limits of our classification system. So these are broad categories. They have overlapping boundaries. Sleep disturbances, for example, can be part of major depression, and they can be part of the manic episodes or manic thing. So the other important thing, and I bolded this, is that they are value-driven. They are judgment-dependent. So it is dependent on the clinician at the time of interacting with the patient. Do I deem this level of sadness or this level of low energy to qualify for a criteria of major depression? So this becomes, the value that the individual themselves describes the experience, and the value and the judgment of the clinician who's evaluating the experience. So it's very, very subjective and value driven. So poor sleep, overlapping of features I've talked about that. So this sort of, classification system is really ill-suited for the AI approach. And so this has not helped us overly well in, for example, in genetics. I was talking to one individual here that was interested in genetics, because you're just including everybody with major depression, and as you see, there's 227 ways to reach that category. So it's highly heterogeneous, highly problematic, and it helps to understand, and perhaps not explain, why we've had such challenges in the genetics world. So this reveals what I refer to as the dark data dilemma. So what are dark data? So dark data, if you just the analogy of the iceberg here, is that when we're doing our research, and I've been involved in ever so many different projects like this, and so the people in the laboratory, they said, well, just give us the diagnosis. All we want is the diagnosis. So we give them the diagnosis, and we give them some other kind of information, the age of onset, comorbidities, do they have alcohol problems, and and so on. So we get a broad amount of this categorical data. Emphasizing again, these are judgment-based diagnoses. And so this is one of the problems that we run into. Now, where are the other data? The other data are, hidden in the filing cabinets. Still, many of these research projects, they were done on pencil and paper, so they're still just filed away in these filing cabinets. I talked to a colleague in London who had data like this. And they're hidden in our servers. And so at Hopkins, we did all this. We've got 90% of the data are just on our computational servers and so on. So make a joke about, we always make fun of our deans and things. And so our dean at the University of Michigan, he wrote this the novel called Coded to Kill, which is meant to be a parody on the electronic health records. And I joked with him and said, the name of it should have been Coded to Bill, because these classification systems are really simply, to help our accountants submit the bills to the insurance companies. So now we're getting into the meat. So I've told you and explained to you the problems that we run into with classification system, major headaches and major problems, that. So we need to think about a different way of organizing our knowledge. And ontology, I think, is a excellent way to think about this. So it's a controlled vocabulary, logically defined, emphasis on defined, emphasis on interrelated terms that are modules of knowledge that we can use to annotate data. They have a definition, they have a relationship, and they're arranged in a hierarchy, and they're able to be recognized by computer languages, the web ontology language, which is referred to as OWL, web ontology language, or the ontology of biomedical organizations. And so these standard ways of representing data. Now, I always like to, share the book that I'm reading nowadays. And so this is a book, Categories We Live By, which is a delightful book to read. And so you go into it initially and you think, oh, God, this is kind of a little bit of, but it rapidly goes into the heart of the matter, focusing on starting with Aristotle's talk about classification system. He was one of the first thinkers really to think about classification, and then getting into some kind of more vague things. Wittgenstein pointed out the limits of my language are the limits of my world. And so what we are describing in with our words describes what we experience and describes our world. So this is a really, really, really interesting book. Classifications, they're broad categories: socio-geographical influence, value judgment, and so we say, what is short versus tall? And so what is short versus tall may be different in one country to the next. And so it's a binary category, right? But you run into all kinds of problems. And so ontology is structured, relational, and computable, and supports reasoning and integration. So now there are three other terms that I want you to be familiar with and to think about with me here. Classification. We've talked about the strengths in classification, the weaknesses of classification. There's also taxonomy, and I dare say that many of you have read or studied biology, and you've been burdened by having to learn the Linnaean, taxonomy. And every time I look at it, I have to read it over again. I can't remember it to save my life, but it's a strict hierarchy, parent-child only, increasing specificity down to Homo sapiens. We're all part of the animal kingdom and so on. And it's it's an interesting way of organizing things. But what it doesn't have multiple relationships. So it can't have, relationships, in multiple directions, or provide the impetus for deep conceptual modeling, supporting inferences and strengths. So I've talked a bit about what is mechanistic AI, but explicitly structured around known mechanisms. So, a mechanistic AI will be the infrastructure around which you approach a problem. So the engineers will have a mechanistic AI as to how to build a building. They don't want to go ahead and start building something just with, LLMs and say, well, okay, the likelihood of this working in this particular way is, or the probability of, having a support system here or there is going to be, is this. So they need to have, a structural foundation of it. And in many ways, it's an ontology-based foundation. And so we can make it into something that we can use. Causality-oriented, pluralistic approach, and iterative in its mechanisms. So that allows for structured learning. In other words, you can improve upon it. Is this way of thinking about something correct, or do we need to alter our understanding of this term? And so I'll show you momentarily how we'd go about that. And so this goes in just the comparison of the black box AI, which this paper really kind of showed us, is that it's just based on statistical correlations. It gets difficult to interpret the models on it, and it's predictions without explanations, and it has a limited clinical trust. I know many of the individuals, researchers here, are interested in trust, and so if we have a mechanistic system that's ontologically based with structured knowledge. And so whenever, many times you hear about people doing analysis, we're using this or that knowledge graph. And I say to them, okay, that's great to use a knowledge graph, but do you appreciate that that knowledge graph has its limitations and is just really put together by people like you and me sitting around a table saying this shall be so. So we want to have mechanisms explicitly represented and have transparent and understandable outputs, and then to support causal inferences, ultimately. In psychiatry, that's obviously more problematic and different. And so the challenges today that we have in ontologies and ongoing development, in the red, the challenges here, when you go into these ontologies, when you go into these knowledge bases, you start to realize very quickly that things are missing and that definitions are problematic, and they have poorly mapped relationships. They're fragmented, and they're weak in their knowledge graph. And so there's a clinical lag compared to what we've seen in genomics and biology. So there's been a tremendous amount of energy, put into genetics, tremendous amount of energy into biology, but there's been a limited amount of energy put into the organization of clinical terms in medicine, but in particular in psychiatry. So what we need to do is we need to enhance and curate, the definitions, that we have. It's very humbling. When you talk to individuals, in the field, they think, we should be much further along than we are, but we're still, struggling in our definitions. So we need to strengthen causal and temporal links, and build these integrated knowledge graphs and enable mechanistic AI and foster global collaboration supporting precision medicine. Okay. Now for the part that is my passion and love. And so I trained in psychiatry at the Maudsley Hospital in London. And so that group of individuals, they're heavily into phenomenology. And we weren't, in my training, we weren't so concerned about what the diagnosis was, but we really loved, just figuring out exactly what the phenomenology that the individual was experiencing, what kind of a hallucination were they experiencing, or what was, what was the level of affect, and what were the components of affect that they were experiencing. So it's a systematic, and an emphasis on the systematic description of a person's subjective experiences and observable clinical phenomenon. So William Osler, in the turn of the last century, he said, that if you can just get the information of an individual, just from the perspective of the mental status examination and what you see, you are 60 to 70% on your way to getting an accurate description of the individual. So phenomenology is incredibly important. And then it has a philosophical root. So many of you have read Kant, in your philosophical endeavors or your undergraduate training, things in themselves, and how do we understand the basic entity, the natural things of the human experience. Husserl was more focused on normal phenomenology as to what is happiness and what is joy, and what are the normal range of experiences that we have. And Karl Jaspers, he focused on the psychopathology. What are the abnormal elements of psychopathology? How symptoms are experienced and expressed. Each of these elements can be organized into modules or units within phenomenology. So I want to just take a moment here just to kind of consider a clinical vignette. So an example: a 35-year-old male presents with poor sleep, plenty of energy, irritability, arguing with everyone. Resentful over the loss of a relationship. His girlfriend left him, and also he's complaining, I just can't focus at work. So So classification overlaps. So the problematic thing I've mentioned, sleep disturbances, that they overlap in mania and depression. So short sleep time, mania individuals, they just say, I just don't need to sleep. You know, I'm getting away with 1 or 2 hours of sleep, just really great. Whereas the depression individual will have just a lack of ability. You know, I'd like to sleep, but I just can't, you know, and I'm just, mad about it. So irritability has multiple categories, can be part of multiple different classifications, either depression or mania. So we're ending up here with just considerable diagnostic ambiguity, and depending on the judgment of the clinician. So the point being here is that in one kind of scenario, the clinician may value or put a value judgment on this as, this is kind of more depressed, and so they will make the case, for this in this particular, way. So looking at from the DSM approach, we have overlapping criteria, mania or depression, the irritability. Could be part of ADHD for that matter. Could be part of depression and the distractibility, unable to focus at work, can be either ADHD symptoms or life stress. Sometimes we talk about adjustment disorders as a diagnosis, and when we don't know what to make of the diagnosis, I'll just call it an adjustment disorder. Where if you think about phenotypic classes, you can think about it from a sleep and circadian. You can break it down into decreased need for sleep with elevated energy, motivated behaviors, and you've got various different ways of thinking and organizing these and that. So then this leads us to cluster-based reasoning. So you have a number of clusters of symptoms that you can organize this into, and I'm going to show you an example of how we can use clusters towards the end of the talk. But the emphasis here is really on the symptoms that the individual has rather than the diagnostic categories that purportedly in. Now, I want to emphasize that ontologies are universal. So sometimes when I'm giving this talk kind of thing, I says, half of the audience now is looking up on Lonely Planet as to where to go to dinner tonight. And so they're going and thinking, oh, gosh, this talk's interesting here, but geez, I'm getting hungry. I got to go figure out where I haven't got a reservation, for the evening. So they go into Lonely Planet. Lonely Planet, and when you look up on a restaurant, it's got all the features of an ontology. It's got the type of the restaurant related to whether this or that food or where it's located. And so you put into, the system a number of different parameters that you're looking for, and the ontological infrastructure of Lonely Planet will come up with some suggestions as to where you would want to go. And so restaurants can be in multiple different categories, and depending where the geographic location is or the type of food they have or the expense category in that. So they can have multiple memberships, and just it's a logical way of doing things. So ontologies, really at the end of the day, what they attempt to do is to put order in the way that we think about things. So the common features, again, maybe pounding this into more often than I should, but the terms or the units and modules, the definitions, the synonyms, relationship, and the standardization and crosswalks and interoperability. And so think of a Spanish-English dictionary as an example of sort of an ontological system that is interoperable, and so you can find the same term in Spanish and English, and they have a common definition and so on. So that's an example of a good system. Now, so those of you that have studied biology and studied genetics, many of you will have come across the gene ontology system, and so they have the three domains describing the genes. So the gene will have, there'll be a biological process, behind it. It may be involved in the circadian rhythm or apoptosis, sort of programmed cell death, or there will be a molecular functioning about it as what it actually does, and it may be part of a cellular component. So the gene ontology is one of the more successful ontologies that is out there. And so when I'm working with people in the lab, my collaborators in the lab, they will be sure to show me the gene ontological infrastructure of a gene and why this may be relevant in psychiatry. So the next thing I want to share with you, tell you about, is the human phenotype ontology. The human phenotype ontology is, again, a standardized vocabulary of phenotypic abnormalities encountered in all human disease. Yes?
Just a quick question. I haven't studied machine learning yet, so I'm just wondering. I guess we have very few people, so I guess.
Oh, you can use the microphone. Yeah, so, they're recording it.
Yeah, you talk about terms, definitions. I wonder whether that's in machine learning they have the supervised learning versus unsupervised learning.
Yeah.
In the supervised learning, they actually give the labels, and they also, I guess, the labels the data.
Yep.
So I don't know whether what you're suggesting here is the same or something similar to the supervised learning, machine learning.
Yes, so it's supervised learning, because it's supervised learning because you're providing the infrastructure, behind it for the learning. So unsupervised learning, as I understand large language models, and I really truly don't have as deep of an understanding of them as I would like, and I don't know that anybody really truly does except for select individuals. But the supervised learning is that you're providing an infrastructure, some guidelines as to how to understand the concepts, and then it goes in and builds the model along the infrastructure that you've been offering. So it's I'm sure that I'm saying this incorrectly, but I see supervised learning in the same domain as mechanistic AI. So mechanistic AI is providing some kind of an infrastructure, an ontology, for example, upon which to proceed in its the analysis of the data. And what I let's see a little bit slower. So I was just talking, so I was going to just introduce the human phenotype ontology. Very similar structure as to the gene ontology with the clinical phenotypes, the biological gene-disease linkages, and the cross-domain interactions of the clinical with the genomics. And so this is a screenshot of what you would see if you went into the human phenotype ontology. And the important point about ontologies is that numbers are assigned to a term, okay? And so this is insomnia, how we understand insomnia in the context of the human phenotype ontology. And so there is a definition, persistent difficulty in initiating or maintaining sleep. There are synonyms that they're offered. There are cross-references to other ontological systems. Remember, the interoperability, is critical. And so the features of it has, as I said, it has a term name, it has a definition, it has the synonyms, it has a hierarchical relationship. So insomnia is described under the sleep disturbance, and it has crosswalks with other ontological systems. So this is the quintessential ontology system in action. And it has also the things that HPO, Human Phenotype Ontology, has is translation. So there will be terms. There's one here, for example, in Chinese. I don't exactly know who has been putting that together, but there is one team that has been working on that. So this slide, you remember I've been talking about the whole problem of sleep. And so the sleep problems are really exemplary in the context of how to think about an ontology and the relationship of terms in an ontological system. So we have here sleep disturbance, and notice, we've got a number for it in the HPO. There are two types of two higher level categories: insomnia and hypersomnia. Insomnia can be broken down into initial insomnia, difficulty falling asleep, maintenance insomnia, difficulty staying asleep, and terminal insomnia, waking up too early and unable to get back to sleep. Now, the various different systems that we have to measure this, and so these names will probably not mean much to you, but there are different clinical instruments to gather information about sleep problems, and all of them do not capture all of these features of sleep. And so that there are some that just, PHQ-9, Patient Health Questionnaire number 9, just captures high-level information. The Quick Inventory of Depression Symptoms captures these informations. The MADRS just asks information about insomnia. The Hamilton Depression Scale captures these 3 elements of this. But you can see here from this is that any symptom of insomnia you can map into this infrastructure, and so then you could find a common way of mapping these terms. And so this is the quintessential feature of an ontology. So, challenges with terms in psychopathology. So we have, observed phenomenology. So when somebody's smiling, and happy, so we can see the signs. We can say they're smiling or they've got a frown on their face. We can define that. And then there are, inferred phenomenon that Kant called noumena. And so this becomes, the clinical art, within psychiatry as to how we define and understand things like delusions, hallucinations, and part of the psychiatric training is how to elicit, define, and record them. And so these are the couple of books that are important to read, and then these are books that you wouldn't necessarily read. Now comes the fun part that is actually a passion of mine. So I'm interested in bipolar disorder. I'm interested in the variability of moods over the course of time. And so we have, many of you have heard about the concept of affective disorders. We talk about somebody, he's got an affective disorder. And so I would, when I was training, I was always running into problems and say, well, what is affect? And what is affect? And how do you define affect? So the fundamental feature of understanding and developing an ontology is you have to have a definition of something. You have to have a definition and being able to break it down. So Emil Kraepelin, at the turn of the last century, he was a psychiatrist in Munich, and so he ran a large hospital, and he would follow individuals over time and write down, when they had an episode, describe the episode, and keep tabs of how things occurred over the course of time. And it was his work in the beginning of the 20th century that helped us delineate what we now call bipolar disorder from schizophrenia. And he did that by breaking affect down into modules, interacting modules. So Kraepelin's understanding of affect has emotion, happy, sad, either high or low. Volition, which is like a drive or an energy, and volition, gets you up in the morning, got you here, got the kids fed and things like that is our drive to and intellect, from his perspective, are your thoughts positive or negative? Are they going fast? Are they going slow? And so there's a dimension, in that. So there's 3 elements here of affect, and I put this in the middle here. So firstly, he noted that these elements of affect could be at the same spot on the curve at any given time, up or down, but they could also be out of sync. So you can have someone with a lot of energy, a lot of volition driving around them, but a low emotion. So they're not happy at all. They've got a lot of energy knocking around, and that's what we call one of these mixed affective states. And these states are dangerous. These are states where individuals do bad things to themselves and do bad things to other people. So these are clinically highly relevant states in that. And so there's a lot of confusion in the classification systems about what mixed states are. And they say, well, you've got symptoms of mania and depression going on at the same time. Not helpful at all because what symptoms of mania, what symptoms of depression are you experiencing? So I want to draw the analogy here to the primary colors. And many of you, how many of you guys learned about the primary colors in school, right? And that was kind of a fun thing. And I don't know about you, but I was absolutely stunned and amazed to see what could come of these primary colors. What do you mean? You mix, you mix yellow and blue, and you get green. Gosh, how did that happen? Kind of a thing. And so, so the primary colors, they're additive by the human eye, and I don't know how many words you have to describe green. I've got light green, dark green, and green. There's the three. So that. But there are a lot of different dimensions. Of green that you can. And so now, you get the picture where I'm going with the concept of affect and the range of emotions that that we can experience. And so affect, can have a range of things for emotion, a range of terms and ways of describing volition and intellect. So what we did was, let me just go back to this. So what we just appreciated that the variability of emotions was of affect, if you will, was a combination of how emotion varied, how volition varied, and how intellect varied. And so that was the project that we set out to appreciate. And I just want to use this example as to how we developed these various different terms. So the process that we used was a Delphi method, of consensus building. So many of you, in economics, I think Delphi is something that you guys are familiar with. And so it's a way of developing consensus, getting other individuals engaged in the process of understanding what a term or what a concept is. So we started out with some workshops and workshops on phenomenology, putting together these terms and thinking about them. Then we had a review, 2 or 3 rounds of the defining and understanding what these terms are. So we had a number of workshops around the world to do this, and so this is the example here of the survey. So we had, you talked about, this is just focusing on emotion. And so we're thinking through, what is an abnormal emotional state? So remember I talked about the fact that you can have an elevated, emotional state or a lowered emotional state. And so the clinicians then also pointed out you can also have emotional dearth or a lack of emotion. So many an individual experiencing depression will say to you, I just can't feel anything. I used to love my family. I used to love going to bed. I used to love, I just have no feeling at all. I just don't feel anything. One person described it in a way of saying, I just lost my soul. I don't have my spirituality. And it is a really, really horrible existence to have. So we defined then, the terms, put a definition behind the terms and the parent terms, and importantly have the numbers, with it. So each of these terms has a number. Why do they have numbers? Because we want to have the computer recognize them. So computers love numbers. And so anything that goes into machine learning or into, kind of a clustering system needs to have a number. And so this is why we're doing this. So we got over 90 responses to this, and we're developing this. We've got papers now that are nearly finished, and so developing and expanding the human phenotype ontology with the terms, definitions, synonyms, relationships, and the crosswalks to other ontologies. So what we're interested in is we're interested in people, that are interested in collaborating around this. And so what we've been doing is engaging individuals from the lived experience community, from the computational community, from the variety of different communities to, participate in this project, to read these terms and that. So if any of you are interested in participating in this, just shoot me an email, and we'll have you participate in online surveys and that. So what we've done for the workshops is that we've paired them with international conferences, getting people together and, and think about, these terms. What I've learned, from this is that people have said, hey, McInNIS, I used to think this was a really kind of a simplistic way, to think about things, but I've realized how difficult it is to really come to a consensus about what these terms really, truly mean. And then I remind them of the fact that, we were all so intoxicated with biology that we've completely neglected, the ontology systems of clinical terms. So, talking with a physicist at lunch, and I'm reminded by the statement that came out of a movie. The universe is a series of approximations, and this is we think about psychiatry being an imprecise field, and then I'm reminded just the definition of sepsis is kind of dodgy in its own right. But then you go and talk to the astrophysicists, they say, we're working on approximations here, and then so the question comes out: what does the Heisenberg uncertainty principle have to do with phenomenology? Well, the more that you know about the individual state, the more you focus on that, the less you know about the trajectory of the person. So it's finding that balance, such as in the Heisenberg uncertainty. They want to know where a particle, is going. The more you know about the instance of the particle, the less you can know about its momentum and where it's going. So it's very, very similar, in psychiatry and in the medical fields, is the thinking about how we understand where an individual is now and where they are going. So, so that I also want to, I've been working with the human phenotype ontology, and I just choose to work with one, but no one ontology will rule. And so when you go to conferences and people are presenting, they'll be presenting more AI-related stuff and more AI, computations and things, and they will say we're basing this on this, knowledge graph and that. So I want you to be aware of what they're saying and ask, so explain to me what that knowledge graph is and how was that knowledge graph, developed, and why did you pick that? And so there are a whole series of, not a whole series, but a number of people that are looking at developing their own ontology. And so, for example, this wonderful person here is working for the Medicare system in the United States, and they need to have a way of determining whether somebody is disabled and whether they should be provided, the disability payments. And so they developed this ontology of mental functioning specific to disability assessment. So when you see, the various different ontologies, a lot of them are specifically designed and developed for a particular purpose. The human phenotype ontology is open science and inclusive of all health conditions. So it's not just the fact that we're working about mental health, but it's how mental health and, for example, diabetes, or how mental health and surgical conditions, medical conditions, any endocrinological conditions, interact with mental health. And individuals with cancer, many, if not most of the people with cancer, they experience at best a sort of a sense of demoralization or feeling low and down, and that. Do they qualify for a major depressive diagnosis? Maybe, maybe not. And then, important thing about it is that it's a value-laden judgment. Oh, of course they're depressed, they've got cancer. But that's not the way we should be thinking about it. We need to know what the features are of that individual from a mental health perspective in order to design and tailor the intervention accordingly. So it's someone who, all they have, because they're worried about their cancer and their future and their kids, is that they're not sleeping well. And so we need to think about interventions that are designed that specifically address the phenomenon that the individual is experiencing. Not to say, well, they don't need X or Y because they don't have this diagnosis, but if they were diagnosed with it, then they could treat them and the insurance company would pay. So it rapidly becomes a very complex, situation. So now we're getting into, so what is phenomenology and what are ontologies going to be able to do? So if you think about this as, a number of individuals, in your favorite diagnosis, be it major depression or, whatever, they're a big lump of things, and they all have a series of, individual kind of symptoms, and that. And so you think about it, a sibship in a family. Everybody's related. They're all siblings, but no one sibling is exactly the same as the next one, and so they all have common features, and you kind of recognize, the Smith family because they're, in this, in that way. But not one of them, is unless they're, identical twins. So it's kind of the same in the classification of medical or psychiatric disorders. But might we be able to identify symptom clusters that we could study? So, for example, we have a group of individuals here that might have a particular subset of sleep disturbances, for example, or such as the case may be. Now, one of our researchers in Michigan used an application of the current terms in human phenotype ontology with the emphasis on the current terms. So we're working on improving these terms by, in mental health by providing a clearer definition of them. So she used clinical notes from the Diagnostic Interview for Genetic Studies, which is one of the diagnostic instruments that we use, or the systematized clinical diagnostic or diagnostic system for the DSM. We augmented it with clinical notes, taking clinical notes and summaries, from our patient data sets. This is from the PMC patient data set. So this is published literature in the from the NIMH PubMed, and then we looked at our own clinical notes from individual encounters with any bipolar disorder in the year 2019 at the University of Michigan, and then we overlaid that with with the HPO terms, 600 terms from the Human Phenotype Ontology. So you were asking about, is this a supervised learning? So this is kind of as I would understand it, and I'm not a computational person necessarily, but this is how I understand supervised learning. You're providing a background or a method or an infrastructure, or a mechanism, if you will, upon which you will do your learning. And so what she found, this is the work of Anastasia Joachim in our group, she found that yes, you can develop clusters. And that, yes, you can find, this is sort of a cladistic analysis, so you can have, high-level, groups, but you can then break it down, into, other subsets, like this is just simply based, on symptoms. So yes, this can be done. And so this is more of a heat map, kind of a approach to it. So you're looking at various different groups of symptoms, and along the x-axis here were the the individual clusters of symptoms. So the next phase of this is so we work with individuals in the Psychiatric Genetics Consortium, and so the next phase is when we can get some granularity and understanding and relationships of the definitions, and that how can we then go back to the iceberg analogy, is that can we put greater granularity in the understanding of the clinical situations or the clinical expressions or manifestations of illness using this type of analysis. And so this is the infrastructure, the mechanistic mechanistic AI that we're suggesting might be a potential use. So, but I want to emphasize, like anything in science, this is not proven. We don't know if it's going to work, but we're excited, to see, what can be done, because the logic and reasoning of using these value-laden judgments of diagnoses that we've been working around has not gotten us there. We've not gotten to the point of having a biological understanding, of bipolar disorder, or biological understanding of any of the psychiatric illnesses. Yes, there are all kinds of hypotheses, and there are all kinds of data sets that will suggest, one thing or another, but they've not been replicated at all. So, final slide here. The emphasis on interoperability being the case here. Everybody's we want to have these fair. This is findable, accessible, reusable data sets, and so this is should be ontologies need to be accessible by everyone. We need to have common formats and tools, and that is already in the case. And the one I'm familiar with is this web ontology language that builds in logic and reasoning, and so that things can be related to one or another, and they're not just a flat system. Shared vocabularies across things. So we want to use these ontologies that have common languages so that we can take one to another. And we don't I'm not married or wedded to any one particular ontology, but we have to be able to use them interchangeably. And then we want to be able to make sure we can design the products or the approach in a way that is shareable, logical, and that. So with that, I thank you very much for your audience, and happy to discuss or take any questions. Thank you.
Thank you so much for the extremely interesting talk. So I was having some trouble understanding when you said that there is no one ontology to rule them all, like different ontologies have different use cases. Then how do you determine the proper use case, and how do you determine the proper ontology to use in a specific case?
Excellent question. And so what we see in in the lab, and I have a graduate student who's working on this. So she's developing, using an ontology that she's using for a specific purpose. Now, what I showed you was the interoperability. And so in the human phenotype ontology, for example, they have numbers that relate to other ontologies. And so again, it's like any kind of method or approach in science. Then you say, I am going to use this way of approaching things because I am doing X, Y, or Z. And so there is, for example, there are individuals that are working on an ontology to understand the options for interventions for mental conditions or mental health conditions. So that one would, kind of say, well, we're going to relate to a diagnostic ontology that would use these clusters of symptoms. And so the importance here of knowing the atmosphere or the environment as to what ontologies are out there, and then knowing which one is more suited to your purposes than the other is part of the experiment. The reason that I like the human phenotype ontology is that it's very broad. It captures all medical and surgical illnesses and all mental health conditions at the same time. So that has the advantage. Now, there are individuals who are very passionate about the work that they're doing, and they say, this one is the best one, and for this reason I'm going to use this one, so I'll advocate. So I'm always worried about that when somebody says, this is, whenever somebody says they've got the best way of doing things, that in and of itself is a red flag. So what you might do and might consider, computers don't seem to mind how much computational work they do. So you could run an analysis using one of ontology A, and then run another analysis using ontology B and compare the results and say this way of organizing ideas seems to be more appropriate than the other. So what I'm cautioning against is this binary selection of things. And so you want to say this is the best and this is what we're going to use. That's not a good way of approaching it. Say, what is the best way to answer the questions that I have? And so with that approach to it, then you will set about to look at the ways of organizing knowledge are, and then make a rational argument for using A or B or C.
Thank you very much, Professor, for the talk. I have a question regarding I just give an example. For example, in psychiatry, there are many disorders that might caused by past experience. For example, a teenager who have depression, maybe it's because there's a frequent argue between his parents, or just for example. May I ask how we can integrate these kind of individual experience into the ontology system?
Yeah. I've got a hidden slide here that anticipates that question. So thank you for that question. So we've been thinking about this kind of a thing. So what you're asking about is so you've got an individual here that you're wondering about. Okay, how do we understand that individual? Okay, so the journey that we went on today was a rather simple kind of structure of ontology as to how we think about one certain thing. But in fact, as you correctly point out, there are multitudes of different elements behind what the individual is experiencing, right? So what you have is that you have the individual with his clinic expressions, and so we know that there are intermediate, phenotypes, behind that individual. So you have a disease concept. So the individual lives with bipolar disorder, has bipolar disorder as an illness, and we know that because they meet, the criteria. They also have neurocognitive, capacities that are to a greater or lesser degree. I mean, they're smart or they're not smart, or they're, have difficulties concentrating, or such as the case may be. We also know that they have there's variableness in their temperament and personality. So some people are just pleasant and happy all the time, and others are not. And there's nothing that you can do. This is as a matter of fact. There are motivated behaviors, and so there are behaviors that people do, what motivates them to drink alcohol, what motivates them to smoke cannabis. There's a lot of these, background things that are going on here. And then there is a life story, or the social processes. And so a life story perspective is what happens to an individual over the course of their lifetime. Okay, did they come from, kind of an abusive background? Did they have and that? So, so our group has been looking at this, and, on our website we have, the papers that we've published, that have addressed this sort of a thing. And then we have sleep and circadian patterns. So some people, they're just night owls, and they work till 2 or 3 in the morning. They sleep till noon. Or then other people, they're there. So there's a tremendous variability in the individual over the course of time, and so we need to pay attention, to that. And so then there's just outcomes. There's just the patterns of what these individuals go through. Now, behind this, these things, I apologize, the graph has got a little bit messed up. Behind these subclasses, there are multiple drivers, that are behind all of these things. And so, so for example, each of these drivers, underlying drivers, are affecting, these intermediate, classes. And so we know, for example, that genetics, affects the disease. We know that genetics affects, the IQ. We know genetics affects, personality. You hear some people say, oh, he's got his Uncle Johnny's temper. Oh, boy, and that. And we know that this malaligned here, but it affects, sleep and circadian. Maybe genetics affects, life story. That's been shown in England that going to medical school has a tendency to run in families, and that speaking Chinese runs in families, and so there are things, that's what we live with, kind of is in that. So on top of all this, there's the factor of time. How does time affect, that? So what an individual, what they did in their teens, in their 20s, and their 30s, has an influence on what happens to them in their 40s and 50s, and likewise the environment. So what I showed you when I was talking about ontology is just a really kind of simple introduction to the way we think about health and about bipolar disorder. It's a very complex condition that that you need to dissect out what these different elements are, and then there are a whole series of specialty fields, psychology, physiology, that are working to understand these conditions. So it's impossible. So what we had, back in the day, this is supposed to point from genetics. When I was, began my career, we were hell-bent for leather. We thought that we would be able to find one gene for bipolar disorder. And so this was because Huntington's disease was mapped in 1983 by Gozella in Boston, and you probably remember that. And there's a cohort of individuals with hair that looked like mine that were convinced that we would find the gene for our favorite illness, and we overlooked everything, that. And so we just went and got individuals. We made the diagnosis, and we were convinced that we would find the disease. What's happened is we've not found it, and we've been humbled time and again. And that's why when I moved from Johns Hopkins to the University of Michigan, I said, okay, we need to reset here. We need to start to study the individual over the course of time and get a clearer understanding as to what exactly is going on. So we look upon each of these categories here as a complex ontological infrastructure system around which to understand the disease. And so I just gave you just a sort of a slight insight as to how we think about the phenomenology of it, but in fact there's really complex systems in each of these things. Now, so my wife, as I mentioned, my wife's a theoretical physicist, and whenever I run into problems, I always talk to my wife, and she's got some insight, lots of insights, and she can provide. So when we're teaching medical students, so we talk about bipolar disorder. So I told you I really only work on bipolar disorder. That's the field that I work on. And I've been incredibly privileged to be able to focus on that. So the classic way that we would talk about bipolar disorder over the years was that you have the manic episode there, and you can see the person jumping up and down in a bed of flowers, where life is good. And then on the other side, we have the depressed phase, right? And so you have the person in the corner being very depressed. And so this is a very simplistic way of thinking about bipolar disorder. And in fact, and so this is where, I just scratched my head and looked at this figure here. So what you have are the measures, the clinical measures of mania in blue there, and the clinical measures of depression in red. And this is over the course of 1 year, the weekly measures of one individual. And so you're looking at this and you think to yourself, holy moly, this is really difficult to figure out what is going on, in this individual. And so then you look at it. So right at this point here, you have depression going down and mania going up. And then we have, this point over here that's the same number, but the mania is coming down. So my wife looked at this and she said, in 2 seconds, you got a bunch of dynamic states going on here, and that. And so to think about, but you think about the human condition. Think about, the bipolar condition as a, kind of a dynamic state in many ways, and that there's constant fluctuation, going on. And how do we start to break down what is going on? And so that led me to think about ontology. How do we start to build knowledge graphs around these various different platforms, neurocognitive, personality, life story, and that. So your question reveals the problem in the fields, that we don't think about this in this concerted way. And so one of the problems. So then the question becomes, and this is relates to the AI story that I told at the beginning. How can we anticipate change, and how can we work towards kind of identifying? Because what we would like to know, and so you have so you have 7 million people here in Hong Kong, and the frequency or the prevalence of is 1%. So you've got 70,000 individuals with bipolar disorder, in the city. Just, we can think about how many of those individuals at this very moment are in one of these positions or these states where they are at risk of doing something untoward or harming themselves, and that. So we need to have systems that we can identify patterns in their trajectory in order to provide assistance to our fellow man, and not just in bipolar disorder, but to any of their health conditions. And so that's why I applaud the work of the the team for the AI, is that this is a start to it, and we need to recognize the importance of it at the same time recognizing the limitations in the current system. And so one of the limitations that I put on this is that we don't have a proper ontology around which to really understand the concepts and the illness. Sorry about taking a long time for the question, but it gave me the opportunity to talk about this. Oh, and the other thing here was Van der Paal's, so this is, no, you're never at the same position at any one time.
This is great. Fascinating. I'm just wondering, I know that you are also an amazing clinician, so can you share a concrete example how thinking based on ontology versus classification shape how you diagnose or prescribe or treatments for a patient that would help us understanding even more clearly how this thinking change your clinical practice?
Yeah, so I can think of any number of examples. An individual, with an underlying bipolar disorder, and so we get the individual on a medication, lithium, that stabilizes, their mood variability. So we're looking at, he really, had a pattern like this, and so now we're bringing down that variability into a certain, kind of a range. So from the ontology of sleep, perspective, he had a difficult time falling asleep. So we had to identify a medication that would help, help him sleep better, and understand that he needed to take those medications. Now, he also had an interest in astronomy. And so he loved to, be up late at night and out there, looking at the stars. He lived in the country, so he had good access to this. And so we need to you need to go to bed earlier. And so we strategized about this and said, well, I've got this computer program, a system where I can let my microscope go on, and capture things. Then I can look at it on my computer, the next day. So talking about, life story interventions, on that. So then, he had, he's got, 3 kids and a family in the area that he finds to be a little bit problematic from time to time. And so he would get irritable, in the part of the day. So this irritability, which is, part of the negative emotions that we have, was a really profound, kind of problem for him. So we identified a medication, Resperdal, that he would take, in the morning, in particular when he is feeling, or about to go and visit a family member or about to do something that he knows he's going to be irritable, with. And so he has a good relationship with me. He reports back as to how he's feeling, and what he's doing at any given time. And so we kind of balance, things out. We work with the primary care doc to make sure he lives 100 miles from where I live. So his primary care doctor manages his, his physical health, including getting his blood tests and everything, done there. So and then unfortunately he had a major major disruption in his domestic relationship, and so then we identified, so there's all this interpersonal conflict, and so we identified a psychotherapist, for him that he's now hopefully has started, seeing that individual to identify strategic ways to manage, those relationships. So thank you for that question, but it really exemplifies, I think, the importance of taking a multi-dimensional, focused approach, and it also amplifies the importance of pluralism in the sense that, at any given time, one symptom category versus another can be more problematic. And so the prudent clinician will just say, you can't just say, well, I'm treating bipolar disorder, this is what I do for bipolar disorder, and then you put in you put in your coin, your nickel, and you get, the treatment. So it has to be aligned with what the symptom profile that the individual has. And so as I mentioned to you, my training was not so much focused on making sure you've got a diagnosis, but making sure you've got the symptom profile and a way to measure the symptom severity and a way to integrate that into what you're doing, and knowing that things can change very quickly.
Can I follow up on that? Thank you, Melvin, and thank you for a wonderful talk. As we were talking about earlier, we hope that this university might get the opportunity to develop a new medical school, and with it comes the opportunity to think about how we approach curriculum and medical concepts and teaching students. Is the ontological approach a different approach to conventional medical education? Is it something that's really well suited to psychiatry and psychology, but not to other things like, fractures and abdominal pain and, ischemic heart disease? Or is there if you had the opportunity to be part of designing the future curriculum for the future doctor, would you do something different to what we all went through?
Well, so firstly, so thank you for the question. In fact, ontologies are available now in most schools, and so you may be familiar with the systematized medical nomenclature, SNOMED, CT, and and so that is available in most places. It's underutilized. It's not utilized really at all. There are other systematic ways of organizing, information through what's called OMOP, the Observed Medical Outcomes Partnership, and that. So at the University of Michigan, there is a lot of interest in implementing that, but there's more will than wallet, at the moment. And at the level of the clinical delivery, and then we're talking about the people delivering the care on the street. I say on the street, in the clinics, if you will. They are more focused on the classification system, and the purpose and the reason for that really goes into because when I interact with a patient, I have to assign a clinical diagnosis, for billing purposes, and then there is a level of care, and I do all those things, pro forma. I shouldn't say that. I do all those things, as required. But what I really think about in the formulation is an infrastructure as to what the symptoms are. So designing a care system and a novel approach to medical care, you have to have a bit of a strabismus, in that. And so you have to have one eye on the accounting office, because they that's what they pay attention to. But you also have to have one eye on the clinical features and how you organize, concepts and ideas. And regardless of whether you're in medicine, surgery, rheumatology, or whatever, I think that the structured organization of that is going to help going to help the accounting in the following way. It's going to help us get an appreciation for the burden of the patients that we're caring for. And so, imagine a moment of time. So you've got a rheumatology patient, then you've also got a metric on, with an ontological system that you click through in order to get a burden of the mood symptoms that the individual has. So I think that, and then the computational capacity of the computers now is really going to lend itself well to that. And so the complexity of the patient, you can have the diagnostic category, initial diagnostic category, but then, and augmenting that with, either with something, it doesn't matter whether you're using SNOMED or, whatever. SNOMED is interoperable, with HPO. What SNOMED is missing, though, is the capacity for definitions. And so this goes into another interesting, element of, medical school and medical training, is that, and I have hold seminars for residents and medical students. I ask them, so what books are you reading? There's a pause. Books? We don't read books. They look things up on the web. So so if we could get some standardized understanding of concepts, that would be available, so we could populate the definitions in SNOMED, populate the definitions in human phenotype ontology. So, because my training, when I was at Hopkins, we used the online Mendelian inheritance in man. You may know of that. And so what we would do, this was in the 1990s, we would go into these big, funny, remember those matrix printers? We'd go in there and we'd punch in the computer all the various different symptoms, and OMIM would pump out a differential diagnostic list that we would work after. So this would, I think, help medical students, residents, and physicians in general to have a structured, organized knowledge graph of clinical symptoms that they could potentially work around to develop, workflow lists. So I don't see them. The important thing here is I'm not saying we don't need a classification system. We need a classification system. There is a purpose for a classification system, but more importantly, we've not paid attention to the. People get mad when I use ontology too much, and that, but we've not paid attention to the structured knowledge graph, the graphs that ontological systems offer. So with that, I thank you very much for your audience.
Yep. Thank you all so much for coming. Thank you, Melvin, for sharing this information. And then one final note, I'll just leave this on. So he did open the door earlier for collaborating with him. I can speak from personal experience. He's extremely open to that. I think it's what has gained him, what's enabled him to gain such expertise in the field. When I met him while doing my postdoc at University of Michigan. I'm in a management department. I was then. I'm clearly not researching bipolar disorder at the time, but through getting to know him, through speaking with him, he was really interested in applying the frameworks from management to bipolar disorder. So he's a great collaborator and he's a great researcher. So other people that are interested in reaching out to him, don't hesitate. If you're junior, he'll point you in the right direction for both your research topic and your career. And if you're more senior, he's a phenomenal collaborator. So thank you, Melvin.
Well, thank you, and just reach out, through Brad. My email is there.
Yeah, he is. So thank you all for attending.
I have a card somewhere too. I think nobody has cards anymore, but I remembered to bring some.
And some people here are still into cards, and I always forget them, and then I show up to places like this. Oh yeah, there's QR codes. I can also distribute an email if people want to know with his email address. Also, if you'd like to email him, don't hesitate to reach out.
Thank you.
Oh, there are cards. All right.
Yeah,
Thank
I do
you
have some
all.
cards, yeah.